we're going to work on writing equations for arithmetic sequences. And there's two types of equations that we can write for an arithmetic sequence. So by now you have learned the shortcut to finding any term, any requested term in the sequence, which we call finding the nth term. But what we're going to look at is two different equations that we can write. So I'm going to split my paper into two pieces, and what I'm going to do, let's see if I can, oops, sorry about that, is this is the long way, and then this is the shortcut. Alright, so those are just my names. Those are not the official names, but I will give you the official names in just a second. Okay, so first thing, whenever we get an arithmetic sequence, we can figure out the 50th term if we wanted to. So let's say we wanted a 50. Now, to just lay it out, just as bare bones as possible, in order to get the 50th term of a sequence, we have to know the 49th term, and then we're going to add d to it. All right, but in order to get the 50th term, we have to know the 49th, but now we need to know the 49th term. So in order to figure out the 49th term, we would take the 48th term and add d to it. But here we have a problem because in order to get the 49th term, we need to know the 48th term. We don't know the 48th term, but we know that we could get the 48th term by taking the 47th term and adding d to it. But here we are again. We don't know the 47th term, but we know we can get it by getting the 46th term and adding d to it, and so on and so on. So you can see why this is going to be the long way of finding the nth term in a sequence. So if we wanted the 50th term, we're basically going to start at the first term. And we're just going to keep adding d and adding d and adding d and adding d. And that absolutely works. So when we were in class and you had to find the 42nd term, we did have a group that counted all the way out to the 42nd term without looking for a shortcut immediately. And it worked. I mean, it absolutely works. The problem is this is the long way. So the name of this formula is recursive. So if you think about what that means, if something recurs, that means it happens over and over and over again, which is basically what we're doing. When we do the long way, we're just constantly adding the common difference over and over and over again. So this is called the recursive form. All right, now what that means is that in order to get the nth term of a sequence, so we said n50, but let's just say generically, if you want any term in the sequence, you're going to have to take the term before it and add d. And if you look, that matches with everything we did up here. When we wanted the 50th term, we used the 49th term plus d. To get the 49th, we used the 48th term and added the d. To get the 48th term, we used the 47th term and added the d. So in order to get the nth term, we're going to have to take the term that comes right before it and add d to it. Now, the problem is that if I told you that the value of d was 5, would you be able to give me the sequence? And the answer is no, because you have to know where the sequence starts. So this is recursive form of an arithmetic sequence. So let's try an example. So let's say, excuse me, that we had, for example, let's say we had 5, 8, 11, ... So if you wanted to find the nth term in the sequence, so write the recursive equation. All right, so if you wanted to find the nth term in this sequence, and again, I'm not asking you which term, I'm just saying how would you write it? How would you figure it out? So if we wanted any term in the sequence, we would need to take the one before it and add 3, and that would get us this pattern. The problem is that if I gave you this information, or if you gave me this information, I wouldn't be able to come up with this sequence unless I knew that I was going to start at 5. So that right here is the recursive form of a sequence. All right, for example 2, I want to go the opposite direction. All right, so let's say, for example 2, I'm going to give you this information. So I'm going to tell you that. All right, and I want you to, and I'm down at the bottom of the page here, so I want you to write the first 3 terms of this sequence. All right, so looking at this information, I know that to get from one term to the next, I have to subtract 2. So I have to subtract 2, subtract 2, subtract 2. But if I wanted to write the first 3 terms, I need to know where the pattern starts. And this sequence is starting at 12. So I know that the first term is 12. And now I know to get every number after that, I need to subtract 2. So the next one would be 10, the next one would be 8, and so on. So that's the recursive form. So that's the long way. It absolutely works. It's not very efficient. It's not the preferred way to find, say, the 80th term of a sequence, but it does work. All right, so now let's go to the shortcut. Okay, so the easiest way for us to get to a term is by looking at the shortcut, which is multiplying the common difference by the number of terms that we need. All right, so we learned the other day that we can take the common difference multiplied by one less term and add it to the first term. But there is a better formula than this one. And to me, the reason why it's better is that we can get to that form directly without having to simplify this equation. All right, so if we were to distribute this, we would get dn minus d plus a1. All right, so I just distributed the d, nothing fancy. All right, so now I'm going to look at this, and let's just analyze this for a second. Okay, this is multiplying the common difference by the term that we want. And we know that we're going to have to do that in order to get to the nth term of a sequence. We're going to have to multiply the common difference to the number of terms we want. But what I want for us to do right here is think about what this is. This is saying negative d plus a1. Well, I'm going to rewrite that because we can. So I'm going to rewrite that as a1 plus negative d, which I can rewrite again as a1 minus d. So now what I want you to think about is if I took the first term and subtracted d from it, I'm going to end up with the term before the first term, which is known as the 0th term, which is weird and crazy, but that is what we call it. So we can find the direct equation as the common difference times the number of terms we want and add it to the 0th term, which technically doesn't exist. but we can say that it's the term before the first term. All right, now this is known as the explicit or closed form. So, if you think about what explicit means, and not necessarily in music, but that's fine also, it's direct and to the point. So, where the recursive form, we kept adding D and adding D and adding D and adding D and adding D, the explicit form is going to allow us to just multiply directly and get straight to the answer we want. All right, so let's try an example of this so you can follow along. So I'm going to call this example 3. All right, let's say that we had 7, 11, 15, ... All right, so I want to take this sequence and I want to write the explicit form. Forgot what I was doing for a second. Okay, so in order to write the explicit form, what I want to do is I want to take AN, and I'm going to fill in DN plus A0. All right, now, I did not specify which term you wanted, and that's because we're just writing the general equation for it. But, and this is going to be very cool, watch this. All right, I know the value of D. The value of D is that I'm adding 4 each time. So, I have my really cool, what are these called again? Friction markers. So, I'm adding 4 each time. So, I know that I need to multiply 4 to the term number that I want. But since I'm not subtracting that 1 from it like I was doing up here, and I'm not starting at A1, I need to come up with what A0 would be. So what we need to do is think about if this right here is the first term, and that's the second, and that's the third, what would be, if there was a term out here in front of the 7, what would it be? And hopefully you can come up with that it would be a 3. And I'm going to put it in dotted since it's not really there. But the 0th term is 3. So now what I'm going to do is replace, oops, sorry, shaking the whole thing here, with a 3. So if I want to get any term in this sequence, I'm going to multiply the common difference times the term number multiplied with, the term number that I want. And I'm going to add it to A0, which is going to compensate for the fact that our our sequence doesn't start at 0, but it does start at 7. But since we're multiplying it by the number we want, we're going to back it up 1. And I really do hope that makes sense. All right. Now, one other quick kind of cool thing here is that a way to check is if I add A0 plus the D, that's going to give me A1. And it's true, because if I took the 0th term and added D to it, I would get A1. All right, last example. We're going to see if we can get this in before our time runs out. So for example 4, I'm going to give you this equation. And then I want you to write the first 3 terms of this equation. Of this sequence, sorry. ... All right, so if we know that this is the D and this is A0, we just said that if we add those 2 together, we will figure out that the first term is 6. And after that, I know that I need to subtract 5 each time. So 6 minus 5 is 1, 1 minus 5 is negative 4, ... All right, that covers it. So again, if you need to rewatch the video, if there's anything that you got confused about, please rewatch it as many times as needed.